we have Melissa Sassi, who is a chief penguin at IBM and also a startup program manager. So she will be talking about how she turned personal tragedy into her superpower, started a movement that taught tens of thousands of youth digital skills in more than 12 countries now, and how you can create your own purpose-driven career too. Over to you, Melissa, and good luck.
We don't hear you, Melissa. Let me try unmuting you.
Unmute. Can you hear me now?
Yes.
Okay, excellent. Sorry if the light is not so good in here. It is actually 3:13 a.m. where I am. So I'm going to zip through this presentation. I'm going to talk about, something a bit lighter than the rest of our ladies spoke about today. I'm going to talk about purpose-driven careers and how you can bring purpose and passion into your career. So first thing is, defining your vision. And I believe in being an and not an or. And that means you do not have to choose between being an entrepreneur and an intrapreneur, an academic or, someone working in industry. You can do many, many different things at the same time. And I know each of us might work in different organizations with different leadership structures. So I think the first thing too is figuring out what is your passion. Do you have a purpose? One of the things that I used to figure out, or when I didn't know what my purpose was the UN Sustainable Development Goals. For me, my purpose and passion is digital inclusion. I'm also passionate about empowering women and girls and reducing inequalities. So a lot of these might resonate with you, but that's kind of the first thing to figure out is what is it that you care about. And then going through and documenting your gaps, being a learn-it-all. So figuring out, what is that thing that you don't know, and how do you keep striving for knowledge? Finding kindred spirits or people within your network who are also passionate about whatever that thing is, whether it's data science or empowering women and girls, empowering youth, and be willing to invest, knowing that in order to incorporate purpose and passion into our careers, we need to invest in that, and it's not going to just, happen organically. And we need to give ourselves space and time. So practicing mindfulness, prioritizing and organizing ourselves, and making sure that, we've given ourselves the time to think about, all right, we have our vision, we have our passion. Now we're taking the time to figure out how do we get all of that together and put something in place that allows us to create a plan and fill in those gaps and own your path. No one else is going to own it for you. But similar to any project, that means establishing a realistic timeline and goals and taking baby steps. It's not going to just happen organically. So I didn't just all of a sudden start going out and teaching, tens of thousands of young people to code or about data science overnight. It happened over time. Now, I know many of us don't have a 9-to-5 anymore. Obviously I don't, because now it's 3:16, so I'm hurrying up to finish my presentation in the morning, and I don't know if any of us work normal hours anymore. But taking on stretch assignments, volunteering with a startup, or volunteering with nonprofits to incorporate that passion, whatever it is, into your career. Again, gather your squad, put your squad together, seek bite-sized insights from them, reciprocate, be a friend, and make sure that you're, really documenting your journey and thinking about how do you portray yourself in a way where others see you in the way that you want to be seen, and you're controlling that narrative in both an inclusive way and doing that both online and offline. The last major step in incorporating purpose and passion into your career is going out and doing it. No one else is going to do it for you. You can find me on Twitter at Mentor Africa with a K. So any questions, I'm happy to answer them in the chat.
That was a great talk, Melissa.
I tried to do it in 5 minutes, which was really, really hard.
I know it is very, very hard actually. So thank you so much, Melissa. It was a great talk, and really sorry that you had to be up like till 3:16.
That's, it's okay. When I said yes, I was on a different time zone, and then I realized, oh no, I'm going to be on Eastern time. So yes, I'm here.
Thank you so much.
Thank you.
All right. So now we can move on to the next talk. So next up, we have Tilila, who is a data scientist at Microsoft. So she would be speaking about the burgeoning field of genomics and how it holds the key understanding and accelerating the cure discovery of some of the most daunting diseases of the century, like for example, cancer, Parkinson's, Alzheimer's, and etc. So the stage is all yours, Talila.
Hi, thank you. You all hear me, see me? All good? You see the
Yes,
screen?
yes, all good.
Sweet. Thank you. Thank you for having me for the second time this year. And I'll zip it in 5 minutes. So just an expectation. This is not just the tip of the iceberg. This is a snowflake on the tip of the iceberg of what this field is all about. But I hope you'll enjoy it. So before we move on, data science, analyze your genome. I need to give you a little refresher on the biology because this is important. And I don't know how much you loved biology back then, but we gotta do that. So let me move my screen. So let's go back to the basics. So if you look at your body, we're all made of trillions of cells. Each one of them has a nucleus in which we have our chromosomes. We got 23 of them. And if you unfurl each one of those, you'll have a string of DNA. And these are made of 4 amino acids: adenine, thymine, guanine, cytosine, ATGC. And this is what makes what we call our book of life. This is it. That's all what we're made of. We have 3 billion of those in our DNA. We all have the same book of life. We all belong to the same race. This race is called Homo sapiens. So especially nowadays in this race talks, race here, by then, we all have one race. It's called Homo sapiens, and we all have the same book. This is why if we have the same blood, we can exchange blood. If we can do organ transplants because essentially we work the same way. So that's the first principle. Having said that, since we all have the same things, sometimes there are differences and variations that can happen in our DNA. We call these mutations. So these mutations, they can be as simple as the one that I'm showing here. So one amino acid that instead of being a G was a cytosine here. Sometimes they can be more complex, and these result in variations that we see. If I were to take your genome right now, I'll find millions of those mutations. The vast majority, maybe 95% of them, are doing absolutely nothing in your body. However, some of them might have some impact. So for example, having red hair is a beautiful mutation, right? And we love red hair, and red hair are still there. So it's a very nice one, just like white peacock. So it's a mutation as well, and we love it. You can think of it as nature being creative, right? However, there are some mutations that are not so good, and they result in what we call genetic diseases. Some of them you might be very familiar with: asthma, diabetes, some forms of cardiovascular diseases, some forms of high blood pressure are genetic. This is it. So, but the good thing right now is that healthcare has made so much strides that now we can contain those. So you wouldn't die of asthma. You'd be able to contain it and live a normal life unless you have some serious condition. However, some other diseases like Alzheimer's, Parkinson's, and cancer, well, are still a challenge nowadays. We're still trying to discover which genes are associated with them. And sometimes even when we know, we don't know much what sort of pathways and issues they're causing in our bodies. So this is a big, big issue for us to make strides. And this is what the genomics field's hope is to further research and identify those genes that cause disease and what they do. And once we do that, well, to be able to screen people and detect this ahead of time. So this is what the genomics field is about. Now, since we are in a data science talk, you'll all be asking, well, where is the data? At which point do we start doing some fun data science on? Well, this is where the data comes from. So how can I get your DNA and analyze it? The process is called sequencing. So I would take your DNA sample in a wet lab. So it could be saliva, it could be a blood drop. There is a sequencing machine. It can be as big as a printer on your office or a refrigerator. So it depends on the machine. And then there is a file that looks like what you see here. The DNA pieces are cut into pieces. And this makes your DNA file. And this could be a really big file, sometimes from 30 gigabytes to 100 gigabytes. And so cloud could be your best friend here, in fact, if you have it. So this is obviously a very simplified view. If there are any people well versed in the field here, they would have a lot of details here to share. So once we have this file, what do we do with it? What are the sort of machine learning, data science processes that we do? So I'm going to mention some of them, by no means all of them. First, one of the first things that you would do is what we call gene prediction. Is this sequence that I'm looking at a gene, or a region that regulates a gene, or nothing, something that does nothing? So this piece is full of statistics as well as pattern prediction. So you look at it and you're like, okay, this looks like an area of the DNA that can hold the gene. So machine learning is also used in this field. Another one is what we call identifying the mutation. So if I see a letter that should be a C instead of a G, is that really a mutation or was it an error? Maybe the device had an issue. How do I know? So if you, for the data scientists of you here, Bayes' theorem would be your best friend in this process indeed. Now, moving forward, things that are more complex, can I correlate between the genes and a specific disease or a body condition? So that's also, as a result of the research, you have a lot of pattern recognition, a lot of supervised machine learning that you would do here to understand how it impacts the different pathways. Once you have that understanding, this gene is causing XYZ, you're able to do screening on patients. And I want to talk about some of the commercial uses that are now available to you. You might find some sites that tell you, hey, send us your saliva, we'll tell you based on your DNA, which diseases you're sensitive to. Well, this is because they've done this process, they're able to do that. I want to talk also about one that is becoming super popular. It's the ancestry. So you do this ancestry test and, oh, you have 75% Britain, 12% Iberian. How do they know that? Well, the way you have the DNA of people from different ethnicities, I say ethnicity, not race again. So, and you will find those regions of the DNA that are specific to them. So then you're like, okay, this is the difference between people from, let's say, China, UAE, Morocco, I don't know, Eurasia, etc. And then you make a pattern of clustering would be your best friend here to see which ones you match. So that's something that's available that you can do, but this is how it works in the background. Last but not least, and this is going to be the last point I'm going to leave you with. Yeah, last point, really. The Holy Grail. Why are we doing all of this? The hope for us is what we call pharmacogenomics or pharmacogenetics. You'll find the words usually used interchangeably. Based on your DNA profiling, can I know which component of drugs would have a good response for you, would have no response, would have a bad side effect? And this is the hope that will make precision medicine, so that we no longer give a drug because it worked on some sample and hopefully it would work on others. This is why nowadays a cancer drug can work on 2 people, have no results on 5, and maybe have side effects on 3 other people. So if we're able to hone this, this is going to be a really, really important and a game changer in the healthcare industry. So this is for me. I leave you with 3 words. If you are a data scientist student, take a bioinformatics class, explore the field. There's a lot to do. If you're a tech entrepreneur, jump in the field. It's ripe, so much to discover. If you're in the healthcare industry, in a hospital, government, or anything, please have a genomics strategy, and I'll be happy to help. So this is it for me. Hit me up on LinkedIn, and hopefully you found this interesting. Thank you.
Thank you so much, Tilila. That was a very insightful talk. I'm sure we didn't only learn data science, but also a lot about biology here too. Thanks a lot. So next up, we have Dr. Neamat, who is an Associate Director of Research at the Heriot-Watt University. She will speak about the basic difference between conducting machine learning research and applying ML for an industry-based use case. So over to you, Dr. Neamat.
Oh, sorry, I was muted. So you can see my slides?
Yep, we can see your slides.
Okay, so well, in this talk, I will briefly go over the main differences between research and practice in the field of machine learning. It is by no means trying to influence anybody what to do. I totally agree with Melissa that you can do several things together if just you understand what you're up to. So, okay, so for some reason, I am not being able to. Okay, so just outlining some main subjects regarding the research and applications. So, okay, sorry. So, giving a brief introduction on machine learning for people who have not heard about it before. So generally speaking, machine learning are about techniques that allow computers to learn without explicitly being programmed. So practically what you need for machine learning to work is to have a lot of examples and to train a model to do some predictions or classifications like what our speaker just mentioned in the area of genomes and DNAs. So recently machine learning have had great successes, and particularly it's very important in the field of data science, because any data science project it will include a component of machine learning. And it's definitely a great direction for a lot of businesses to pursue to increase their value, and machine learning skills are very much in demand in the data science field right now. So yeah, so looking at research and application, I've done some small exercise like in 2015, trying to understand by looking at the keywords or the topics in my favorite machine learning conferences, international conferences, what are people trying to present and what are they interested in? And I noticed from 2005 and 2015, there is a very clear trend on the evolution of the field of machine learning into turning into models that can deal with bigger data, that are faster and more or less also more intelligent. So more intelligence is always incorporated in the field. And now I did this exercise and looked into in 2020 and the forecast above what are people mostly working in the field of machine learning. And obviously the advances in the field of vision and natural language processing is so vast now that there is a clear trend of machine learning going into what we call the general artificial intelligence, which is somehow which is a kind of trying to make machines and computers as exhibiting the same intelligence like humans. Also in applications, we have seen the widespread of applications that incorporate fields of healthcare and retail, market, transportations, and you can name others. And also that are incorporated in many products, to the extent now that the innovations of the self-driving cars and the personal assistants also include a component of machine learning in the back end. Also, businesses have benefited a lot from machine learning systems to improve their profits and to give a better customer experience. So, well, this is just a quick outline, or what are the basic topics we talk about when we talk about machine learning. I'm not going to go into details. So, supervised learning, unsupervised learning, evaluation criteria, and neural networks models which were available since the 60s. But now new advances like deep learning network have also been quite in focus. So talking about machine learning research, how do we do research in the academic field? So usually you start by something called the state of the art, or knowing what is the most up-to-date in a certain field. And then trying to identify a gap, meaning a question, something that is missing, suggesting a solution, then for this solution, providing some either theoretical analysis or empirical results, which mean an experimental. And then coming up from this with recommendation and suggestions for future work. So what is actually scientists trying to do, researchers? They are trying to advance, push the boundaries of science and go beyond the current state of the art. And in a way, they always want to suggest new ideas. And very important is also to create foundational knowledge, meaning to educate the reader as to be able to build upon this current knowledge. Also very important is...
You only have 1 more minute remaining.
Okay, so also you want to highlight open questions and be clear of it, and try to make research that is also applicable for the real world. So, very important. So it's not about creating a software or creating a product. It's about proposing new ideas, even if they're not quite applicable at the moment. So the research outputs are in the form of a paper or a form of a patent or whatever, but not necessarily. I'm not saying that all researchers have tried to satisfy all these points, but if you are interested to know about some troubling trends or things that are not working quite in the research right now, you can look at this paper, recent paper. In practice, it is different. Usually you look into the domain, a certain use case, you acquire domain knowledge, you try to collect the data and prepare the data for your application, which is quite a tricky and time-consuming process. You build the model, you optimize the models, you present the solution to the stakeholders or your superiors, and then you launch and maintain the model, which is quite a complicated also process. So it is actually about production, whether it is a production software product or just a prototype and a proof of concept. So here, what you want to do, you want to translate the research into the latest research into a prototype, and you want to provide a current business value. So here, because the process is complicated, so the machine learning production is very complicated. If you are interested, you can look into this this paper that outlines the complexity and the scope of the surrounding the machine learning infrastructure. Therefore, we find in this process a lot of roles that take part, from data science, machine learning engineer, and software developers that have the expertise to be able to cover the requirements of a machine learning project coming to production. My final take on that is just, I believe that research and practice are very much intertwined. So data science or practitioners need to be updated with the latest achievement in research to be able to apply it and to solve new problems. In the same time, practitioners feed into the process of the research, because through applying the state of the art of the research, they are able to outline the capabilities and limitations, and then drive the research and the innovation forward. A very also interesting trend is the fact that when the research is visible and is interesting, it also draws attention for the investors to adopt technologies. I know that some technologies have been adopted based on one single paper that was published, and in this way leading to more practical innovations in the light. So thank you.
Thank you so much, Dr.
Questions?
Neamat.
I thought I didn't have the, I rushed to the end to.
Oh no, it was actually a really great talk. Thank you so much. So next up we have Dina. So Dina is the head of data science at Property Finder. She will speak about data products, the key differences, and how to navigate the culture change required to deliver successful data products. Over to you, Dina.
Great, thank you very much. I'm going to do my best to keep it to 5 minutes, but it runs away with you.
Yep,
So,
I will keep a warning.
okay. I have a timer. So hi everyone. I'm Dina, Mohammed, Laity. It's great to be with you today. I'm currently at Property Finder and I'm head of data science there. I've been in the data industry for a number of years across a few different industries, and I am here today to talk to you about data products, picking up from what Neamat just finished actually, so it's good timing. So at first I thought I could tell you about our ranking algorithm or price trend tools, how we made them, maybe something with image processing, but actually I realized all of those projects had one big thing in common. And when it comes to answering the question of how you deliver a really great data product, most people don't really like the answer because it's by failing a lot. I call it failing with style. So it's not something we normally like to talk about. It's a bit uncomfortable because failing's bad, right? Because it makes you a loser. Except really, it's not. Because if you think about it, I mean, machine learning, what is machine learning if not a huge series of very rapid failures? And the truth of the matter is that making data science projects a success is really hard. You can have the best idea, the best algorithm, the best written code, the best developers, but without the right framework and without the right culture to deliver, you're just not going to see any success with the project. So I think it's worth discussing briefly how a data product is different to a regular product, because this is often a source of misunderstandings and some failures. So this is the famous double diamond approach, and indeed many parts of it will apply to data science projects, but there are some really big parts that are missing that we could talk about today. It's like uncertainty, data quality, issues with deployment, monitoring, evaluation, and drift. I'm sure some of you guys in the industry will be nodding your heads right now. So instead, I propose this as our double diamond. I've actually stolen this from my friend Jan Teichman in the UK. And you can see from this the opportunity for chaos. I think it looks like a washer dryer. The right side element is the biggest difference. There's so many routes that you can pass through, so many loops, complexities that arise. And actually you can fall at the very first point if you don't have sufficient business and data understanding. And if there hasn't been enough investment in the foundations and you have a data source that's on fire, like in my picture here, then you'll probably fail, or at least you'll spend a long time on the data prep element. Not to mention that moving into deploying and monitoring, which is certainly easier these days than they used to be, but nonetheless, there are complications along the way. So the point being, there's a lot of opportunities to fail. And the other issue is regarding deadlines, which is obviously a common way of how we work. They're often based on traditional, more predictable understandings of product management. And some examples here that you can totally blow and agree: timescales, data issues, model specification. The model might just not work. It might just turn out to be a bad idea. That's okay. And then a particular issue I wanted to highlight in this setting, as we're talking about women in data science, is the curse of perfectionism. Now, I did a Google search, it's a bit depressing, around the relationship of gender and perfectionism, and there are a bunch of studies showing it. And it's obviously not a female-only issue, but it is quite a common one that arises. And I found these quite alarming headlines as well. And it's something that we have to be aware of. Being aware of your possible weaknesses and blind spots is really key, and perfectionism can be your enemy. So, in this case, you have to build in a failure rate, and you just have to be okay with that. Accepting that failure is going to be an important part of data product development from the outset is vital. So it's all nice and fluffy, but we work in the real world. So how can we make this work? Here, so I've got my 3 key tips basically for how to communicate in a way that will help you get through with your data product development. Firstly, be honest. Being honest about your epic track that you're going to have to undertake will get you more support, and you'll probably get kudos for being candid. Here's one for you to screenshot for later. Maybe stick this on your desk if you're going to be making data products. Secondly, finding a way to engage your stakeholders along the way will definitely help with your process. This is how we do it. We do live data prototyping using something called Dash by Plotly. So you can show, not tell, it's vital, and then get input, and then take people on the journey with you. And then finally, related to the engagement piece, having clear milestones, you showing progression, explaining the blockers, telling the story, absolutely vital. And then very, very briefly, I'll just share very quickly my favorite failure. We had an amazing product. We were really excited to launch it. It was an amazing recommendation system and it had all these fancy technical elements. We were really proud. This was the plan. I was going to be front page news. The team would be basking in glory, fireworks and everything. But unsurprisingly, it was a massive failure. It's a huge flop to begin with. It just didn't work. It didn't have the impact that we'd hoped for. And so we kept the old rules-based system. But so what? Was it a waste of time? Well, this is a mantra I like to live by personally. And we applied this. We got up the 8th time. We created new hypotheses. We tested them. And eventually we ended up with a great result. But that was all because we followed the principles that I've shared with you today about how to deliver kick-ass data products. Here are the main things. Just being open to failure, embrace it, aim for milestones and don't race to deadlines, and show, not tell. Data prototyping is a winner. And that's it from me. Feel free to reach out or ask any questions. And thanks for listening.
That was amazing, Dina. It was a great talk. We certainly did learn a lot of principles today about delivering successful data products. Thank you so much. So, last but not least, we have Divya Sharma, who is the Global Business Services HR leader at IBM. So she will be telling us about how you can achieve a career in data science before we move on to the career panel with her, along with some of the amazing women. Stage is all yours, Divya.
Hey, thank you, Anchal. And, hello, ladies. What an incredible morning it has been. Truly appreciate everybody's insight. And quite honestly, I don't know what else I can tell you that we already haven't learned from these incredible ladies. But I will take you through some slides that I came across a few days ago from none other than our incredible Melissa Sassi. So thank you, Melissa. I'm sort of just stealing your slides, but you can't make perfect any better. So, unapologetically, I'm just going to use Melissa's slides to give you an insight into what a career in data science looks like. And I have turned on my timer, so hopefully I'll be on time. As we've been hearing that the world is becoming more and more data-driven, and a lot of firms say that they're becoming insights-driven, but not a lot of them are succeeding. And there are a number of reasons, but we think that the number is like 5%. So what this means is that there is incredible opportunity for a career in data science for anybody who cares about and who has a purpose, as Melissa described earlier. Now, data scientists most definitely aren't people in a basement crunching numbers behind closed doors. They're incredibly talented people working on real world business problems and creating solutions to make the world a better place for us all to live in. And that's the power of data science. Dina touched upon this in her lightning talk. Apart from having the technical skills, a good data science is at the convergence of computer science and IT, math and statistics, but most importantly, domain and business knowledge. And one of the ways that we engage stakeholders in problem solving is through design thinking. And that is really, really key as we look forward to building our careers in data science, to take the stakeholders and the end objective view into consideration as you build your hypothesis, etc. So this picture actually perfectly describes, what we're trying to build. This car or this whatever it is, it's a vehicle, may be a perfect sum of all parts, but does it represent a beautiful outcome-oriented solution to a business problem? I'm afraid not. So unless there is business strategy at the forefront, and this is a really, really key skill for any data scientist to have, your result is not going to bring about the impact that you would like it to bring. So important to understand business purpose and strategy, be a part of a diverse and inclusive team. So a data science team has to be as diverse and inclusive as our speakers in this call today, different skill sets, different backgrounds, different points of view. Design thinking is really, really key. And as Dina said, we have to be agile, be prepared to fail and test and learn and use data to drive insights and objective decisions. Fail fast, get up again, get up the 8th time and move on. How do we move up the data value chain? And this is really how a data scientist's value come into play. For the first path would be an integrator who understands the data for the organization. Moving on to, let's say, using data and analytics for decision making, but then moving on to use insights to predict business solutions, change in business models, create new value, and provide data-driven insights to drive key business decisions to go up the value chain. Data scientists are not single unicorns. They are a part of the unicorn team who can achieve greater results as a sum of many parts, right? Diverse and inclusive teams are really, really key. And they require teams from people from all sorts of disciplines. We saw how data science is influencing healthcare, medical science, driving property-related decisions. We looked at how it is driving cybercrime. It's looking, predicting, and avoiding cyber criminals. So it's a really, really well-rounded discipline with no dearth of what you can really grow your careers into. But more importantly, it is a team sport. And again, starting with the organizational or the business outcomes and how it would bring value to the client is being really, really key. There is no dearth of applications across industries, but the team will depend on domain expertise in one of the industries that it is looking to serve. The secret ingredients, right? So there aren't really a lot of secret ingredients. You will see it is all coming together as we have been discussing today, starting with business acumen, a strong analytics knowledge, and visionary storytelling and presentation skills, apart from understanding the basic data understanding and data management skills. So the good news is that there is a job for everyone. It doesn't matter what industry you belong to, right? And with this, the world is your oyster. But don't forget to be agile, and hard work is going to be really key in making sure that your dreams come true. Anshul, thank you very much. And this is the end of my presentation. I hope I haven't overshot too much.
Oh, thank you so much, Divya. It was actually a very great presentation, and we learned a lot about new terms and about career in data science. So thanks to all the Lightning Talk speakers. So, and I think now we can move on to the panel. So over to you, Chada.